Okay, we're going to talk about work and power. Okay, power. So the formula for power is going to be work divided by time. That's your formula for power. And we must remember that the work is equal to delta KE, which is the increase in kinetic energy. Let's make this K a little better looking. Here we go. This is a K right here. And this is equal to 1/2 of the mass final velocity to the square minus 1/2 of the mass initial velocity to the square. So this is a V. There you go. So we got this formula, and we got the formula of power right here. So this is going to be work and divided by time. Okay, so let's do an example. Let's say that we have here uh, a particle or a little car, something that goes this way here. And let's say that this is the floor right here. And let's say that your little vehicle, here's the wheels of your vehicle. Okay, here is the vehicle, and it's going to pass through point A. Let's call this point A. And when it comes, your vehicle is coming here, it's going to pass with an initial velocity of, let's say, 25 meters per second, 25 meters per second. And then it's going to continue in its path. And then it's going to pass over here through another point. Okay, here's your little car right here. And let's call this point, let's call this point B. And the velocity, which would be the final velocity when he passes through point B, is going to be 50 meters per second. Okay, so what happened here? Well, eventually, well, as you can see here, there's going to be a change in the velocity. That means there is some acceleration. Acceleration is going to be delta V over delta T. And as you can see, the velocity has changed. And they're asking us to find the power. What is the power in this phenomena? What is the power for this increase in velocity? Well, we know that the formula says that power is going to be the work divided by the time. And we know that it's going to be 1/2 of the mass final velocity to the square minus 1/2 of the mass initial velocity to the square divided by the time. And let's say that the time it takes to go from point A to point B, it's going to be, the time is going to be, it's going to be 2 seconds. 2 seconds, it's going to be your time. Okay. So let's get the power here. So the power is going to be equal to, they're going to give us the mass 2. The mass is going to be 1,200 kilograms. That's the mass of your car. It's going to be 1,200 kilograms. So your power is going to be 1/2 of your mass, and your mass is 1.2 times 10 to the third power kilograms. And you can factorize this one right here. It's going to be 1/2m. You can just pull it out. So it's going to be final velocity to the square minus initial velocity to the square. And you have factored the mass right here. You can factor it out of the, because it's repeating on both terms. So you can just pull it out, and you can also pull out the 1/2. And don't forget, you got time over here. Okay, so here we go. So we have done that, and then we have this one, which is going to be 50 meters per second, but you got to elevate this to the square minus 25 meters per second, and then you got to elevate this to the square right there. And you have to divide all this by 2 seconds. Okay. So the power is going to be, if you do this one, it's going to be right here, 1/2 times 1.2. It's going to be 0. It's going to be, okay, so it's going to be 1.2 divided by 2. It's going to be 0.6 times 10 to the third power kilograms. And then here you have 2500 meters square over second square minus 625 meters square over second square. Okay, and all this has to be divided by 2 seconds. Okay, so this is going to throw you, let's see, what do we get here? This is going to be, okay, it's going to be 2500 minus 625, which is going to give you 1875 times 0.6 is give you 1125 divided by 2 is going to throw you 5562.5 times 10 to the third power. So what do we have here? We have kilograms. Okay, let's get the units going here. Okay, we got kilograms here. And then we got meter over second square times meter. That's at the top. And then at the bottom, we have seconds right here at the bottom. So this is going to be Newton meter is going to give you joule. This is going to be joule divided by second. Okay, so your power here is going to be 562.5 times 10 to the third power. And joule, okay, it's going to be joule because kilogram meter second square is going to give you Newton. Let's put the Newton right here. So this is going to give you a Newton. So this is going to be Newton. Let's get it right here, right? So it's going to be Newton times meter, which gives you the joule. And you end up with joule over second. And that's going to be watts. So it's going to be 562.5 times 10 to the third power. And it's going to be watts. Okay. So that's going to be equal to 5.63. We can approximate times 10 to the 5 watts. And this would be the power that has been developed by the motor and that has produced that change in velocity. And there you go. You have an example where you have used the definition of power. Remember that power is the work divided by the time. Work divided by the time. Thank you very much. I'll see you next time.